Hello everyone, I'm Riku Ala-Laurinaho and I work as a doctoral candidate at Aalto University. I'm going to tell you about GraphQL Interface for OPC UA, which we implemented for an industrial overhead crane. This paper is based on the master's thesis written by Jani Hietala. The structure of the presentation is as follows. First, I will present the motivation and why we have done this interface. Next, I will quickly introduce the OPC UA and GraphQL, and then I highlight the differences between GraphQL and the rest, which is currently the most common style for implementing web APIs or application programming interfaces. After that, I will present the GraphQL OPC UA wrapper implementation. Then I show the measurement setup and results, and finally conclude the work. So let's move on to the motivation for creating GraphQL Wrapper for OPC UA. Smart factories and Industry 4.0 require intelligent machines to communicate with each other. OPC UA is a common industrial protocol to enable communication with industrial machinery. However, the communication with OPC UA is relatively complicated because the several handshakes required for connection establishment, as can be seen from the picture on the right. In addition, web developers are not often familiar with OPC UA, and web protocols are more scalable, efficient, and suitable for constrained devices than OPC UA. Therefore, several papers have proposed solutions to allow RESTful communication with OPC UA. In this paper, we implement a GraphQL wrapper for OPC UA to enable easier communication and application development. At the bottom of this slide is a picture of an overhead crane called Ilmatar, which is located at the Aalto Industrial Internet Campus. The crane is used as a part of research and student projects. In addition, we are creating an open innovation environment for the crane, which would allow third parties to develop applications for the crane. Like many other industrial internet devices, the crane has an OPC UA server for communicating with its PLC system. The GraphQL wrapper would allow an easy access for the internal sensor and control values of the crane, and thus make the application development for the crane easier. What is OPC UA? OPC UA is an industrial protocol for communication which is standardized in IEC 62541. It is currently developed by OPC UA Foundation. OPC UA is platform independent and suitable for many industrial fields and applications. It supports both client-server and publish-subscribe communication models. In this paper, the focus is on client-server communication, in which clients use services provided by servers. These services are used to interact with objects which are presented as nodes. Nodes can be used to present real-world entities and can reference to each other to describe relationships between these entities. Each node belongs to a certain node class, which defines the attributes of the node. The attributes might also include metadata. What is GraphQL? GraphQL is a query language and also a runtime for performing queries on the server side. It was first developed by Facebook, but has been open sourced in 2015. On the upper right corner, there is an example of GraphQL query. As can be seen, all requested fields are defined. This makes the response predictable, as response contains only these fields. In addition, API-specific parameters can be defined, like genre in the example query. The right bottom corner shows response for the example query. GraphQL queries allow requesting data from multiple objects with a single query. In the example query, also data from author is fetched. What are the differences between REST and GraphQL, and why we implemented GraphQL Interface instead of REST? Both GraphQL and REST are used in APIs. REST is actually an architectural style, but HTTP APIs are often called REST APIs, even though they seldom follow the architecture completely. REST uses HTTP methods to implement create, read, update, and delete operations, whereas GraphQL has API-specific methods. Queries to GraphQL API can be sent using HTTP GET or POST requests. The benefits of GraphQL compared to REST API are as follows. A single query can interact with multiple resources. Ability to introspect the schema. The format of response is always known. The hierarchical structure of GraphQL matches well to the information model of OPC UA. And GraphQL supports subscriptions. Let's take a closer look at the GraphQL wrapper. So the idea of the wrapper is to provide an additional interface for industrial machinery, in our case overhead crane. The wrapper translates GraphQL queries from clients to OPC UA service requests and forwards them to the OPC UA server. The response from the server is also translated to GraphQL and passed to the client. Thus, developers have to be familiar with only GraphQL, not with OPC UA. The currently supported operations are shown on the table 1. Multiple requests from a client are often batched into a single OPC UA service request. For the first query to an OPC UA server, the session has to be established to the OPC UA server, which requires several handshakes as mentioned earlier. Therefore, the execution of first query takes longer. However, subsequent requests use the same session, which reduces the request execution time. The wrapper was implemented with Starlet Python Web Framework and Unicorn Asynchronous Server Gateway Interface Server. Starlet was chosen because it is considered one of the fastest Python web frameworks. Graphene library was used to build the schema, and communication with OPC UA server was implemented using Python OPC UA library. The GraphQL wrapper is also containerized with Docker to allow quick deployment. In this video, I demonstrate the introspection ability of the GraphQL API with an overhead crane. It is easy to find the needed values, such as the hoist position and load. From the introspection view, it is also easy to see the hierarchical data structure of the OPC UA server. The second video demonstrates the control application, which uses GraphQL Wrapper to communicate with the crane. On the right, there are buttons to move the crane. On the left, user can define values which are monitored from the OPC UA server. In this case, the speed of the crane and the location of the hook. It is also possible to view the IP camera attached to the crane from this application. The performance of the wrapper was tested with the shown measurement setup. In the setup, 2 laptops and Raspberry Pis are connected to a switch. The GraphQL wrapper was run on the Raspberry number 1 and the OPC UA server on the Raspberry number 2. Laptop number 1 acted as a client sending requests. The network traffic was mirrored to the switch port 8 and the second laptop captured the traffic using Wireshark software. The test included reading and writing 1, 5 and 10 values to the OPC UA server directly and using the wrapper. Each test was performed 50 times. The results show that the wrapper increases the latency significantly. On the left are average latencies when requests are performed internally on the laptop, so that the laptop runs both the wrapper and the OPC UA server. It can be seen that when reading data, the processing of the query takes most of the time, whereas when writing data, constructing the request takes most of the time. When using the test setup, where OPC UA server and the wrapper are run on Raspberry Pis, the latency is substantially higher. This can be explained by the difference in computational power between the laptop and Raspberry Pi. Increasing the number of values to be written also increases the latency, and it exceeds 100 milliseconds with 10 values. As a conclusion, GraphQL Wrapper allows quick application development for cyber-physical systems and Industry 4.0. It bridges the gap between web technologies and industrial applications. The wrapper was built using Starlet Python Web Framework and Unicorn server. Its use was demonstrated with crane control application, which also allowed monitoring the status of the crane. The measurements show that wrapper significantly increases latency compared to direct request to the OPC UA server. However, latency is still suitable for many applications. The future work includes improving the performance of the wrapper and testing it with other machinery with OPC UA servers. Thank you for your attention. Here are the references used for this presentation.